Hello everyone. Welcome to the live session. I hope you are doing well. Today we are going to learn a very important Terraform concept which is commonly used in real world projects. Okay. So yeah. We already seen for each and all. Okay. To set and all and Terraform meta argument for each chaining. Today we'll see and creating multiple Azure Linux virtual machines dynamically. Okay, we'll see. And by the end of this session, you will clearly understand why for each is preferred over count, how for each works internally, and what for each chaining means, how to implement it in a real Azure VM use case. So this topic is important. Okay, project important and production grade. So let me write today's topic. Yeah. So what is a meta argument in Terraform? Okay. What is a meta argument in Terraform? So in Terraform, meta arguments are special arguments, that control how resources are created, not what they create. Okay. So you have to be careful on that meta argument. So I'll write the definition here so that you can take as a revision part. Yeah. So what is meta argument in Terraform? So in Terraform, meta arguments are a special argument that control how resources are created, not what they create. Okay. So common meta arguments are we have you know some common meta arguments are count for each. Now we are studying for each. Okay, depends on life cycle. Okay, So this is the example I can say for common meta argument we have. So today we focus on for each. Already we seen count. Now we are focusing on for each. So what is for each? I already explained you what is for each. For each allows Terraform to create multiple instances for a resource based on a set or a map, we can say. That is for each. So I'll write here based on a set or a map. Okay. So example, I'll write here. Okay. We already seen this day before yesterday and all when we have previous live class. Okay. So here Terraform will create two VM1 and VM2. Okay. One resource for VM1 and one resource for VM2. So each resource can be accessed using each dot key and each dot value. Okay. So I already explain you the difference between for each and count. Okay, you can see here count and for each. So works with number, and we can say it uses numeric index. Okay, so we have index shifting problem we have in count. So hard to map dependencies and all in count. But if we come to the for each, it uses the meaningful keys. Okay, and stable resource identity we have in for each, and clean dependency mapping here. Okay, in for each, I can say. So this is the difference. So in production, for each is safer and cleaner. Okay, so what is for each chaining? So now comes the most important concept. Okay, for each chaining means using one resources for each output directly as the for each input of the another resources. Okay, so very important concept for each chaining. Okay, for each chaining means using one resources for each output directly as the input of other another resources. Okay, okay. So Terraform resources created using for each appear as a map of object. Okay, I already explained you, And so we can, I'll write here example. Yeah, so we can write for each as a, like this. Uh, for each equal to Azure RM underscore network underscore interface dot my VM NIC. So this creates a one-to-one relationship between network interface as well as the virtual machines. Okay, this is exactly what we want in real project. So let me write here. Okay, yeah. So let me write the code for you here. Hmm, Terraform live session. Zero three zero one 2026. Let me open in VS Code. Okay, code space dot. Now I need to check in which we have the VM code. Hmm, yeah, on 26th we did that. Zero 03. Hmm. I have resource group here. Okay, so I want to delete it. So I'm trying to. On 30th I created resource group, but I forgot to delete it. So I'll delete it now as using command terraform destroy. So you can also understand the command terraform destroy. Yeah, DC1 apps, DC2 apps, DC3 apps. Okay, as you can see on 28th. Yeah, on 28th we did that. So now I have to go inside that directory cd 28. Now I have to run terraform destroy auto dash approve. So while it is destroying, let me open this too. 01 space DEC 2025. Actually, the code is the VS Code. I open in VS Code, so it is asking to try again. Okay. Yeah. Now destroy complete. 3 destroyed. Okay. Now if I'll do refresh here, you can see that resource group has gone right now. Okay. So yeah. Now I'm going to close this VS Code. No need. Again I'm going to close this. No need. Now yeah, come to this folder. Let me try again. Yeah. Now yeah. Now I want to open my VS Code in this directory. Okay. So code space dot. Yeah, no need to explain this code and all. You already seen that. Okay. Just I am talking about the key concept, today's key concept. Okay. So let me bifurcate all these. Today I'll create different file. Okay. Version.tf, version.tf. In version.tf, what I'll put? I'll put this Terraform block as well as this provider block. Okay. Control X, and I'll do here Control V. Okay. Now it came into version.tf. I'll write versions. Now I'll write resource group.tf. Resource dash group.tf. Resource dash group.tf. Okay. So in this file, I am going to keep my resource group code. Let I write here only. TF. I'll do later. Okay, when it is required. So here we have public IP. Yeah. So what I am going to do, I am going to, yeah, I am going to create public IP. Okay, from line number 40 to 48. The different resource block for public IP. Okay. Yeah. These two block I need to change the name. Separate name I need to give. So I did here as two. Okay. Yeah. If you understand this code, okay. So for each creates two public IP for VM1 and VM2. These are VM1 and VM2. Okay. So resource name becomes, Azure RM underscore public underscore IP dot my public CIP VM1 CIP2 VM1. Let me copy this. So resource name become, okay. So each VM get its own public IP. Okay. So let me give let me delete this public IP, so it will confusion for you guys. Okay. Yeah. Now network interface, you know with for each we can do NIC. Where is my NIC? Yeah, here. If you can see, The normal NIC resource block looks like from line number 75 to 86. Okay, in which we have the name, location, resource group name, then IP configuration. We have name, subnet ID, private IP address allocation, and public IP address. Like that we have. Okay, so let me copy a code for an IC, but I need to copy here. For public IP, I need to change the resource group block name here. So what is the resource RGS1? Okay, then I see for each. Now I need to do. Okay, and it is asking about public IP, my public IP. Okay, so this is attached to this public IP. Okay, public IP, public IP. So here, same for each key is used in public IP. Okay, and we map public IP using no Azure RM public IP dot my public CIP is dot key dot ID from here. So BM1 NIC gets BM1 public IP and BM2 NIC gets BM2 public IP. NSG, I'm not going to change anything. NIC, I'm going to delete this. So if I do some changes in that public IP as well as that NIC, okay. So first of all, I'll write here that is depends on for output block. I'm going to create a new file output.tf. Okay, output.tf, and I am taking all the file from here to output.tf. Here we already have depends on Azure RM network underscore network interface. I'll write here for each. Okay, for each Azure RM underscore network underscore dot my VM NIC. So here I'll give my Linux VM dash dollar each dot key. Okay, computer name same, resource group okay, location okay, size okay, admin user okay, network interface. Yeah, for network interface, for network interface IDs, that is correct. Ajivaram underscore network underscore here, and here I need to give each dot key. Okay, and disable path false. Okay, OS disk we need to give name as like this so that it will create two VM. Okay, yeah. Now let me explain this for each. Okay, so I'll take this code. Let me first take which code I taken. Hmm. The NIC one. Hmm. Yeah, this code I need. Then we need this. Yeah. So we need to relate correlate this three code so that you can understand in very uh, good manner. Okay. So you know that for each equal to Azure RM underscore network underscore interface dot my VMNIC. Okay. So what happens here? Azure RM Terra network underscore interface dot VMNIC is a map. Okay, is a map, and Terraform loops over NICs. Terraform loops over NIC. For each NIC, one VM is created. Okay, for each NIC, one VM is created, and this ensures one NIC, one VM. So perfect one-to-one mapping. This is called for each chaining. Okay, this is called the for each chaining here. So I think I'll get some error on that. Let me first delete which resource group I named here, my RG dash 2. I need to delete this resource group, else it will conflict. Okay, so deleting resource group, we need to click on resource group, delete resource group. Then I need to copy this name and paste it and click on delete button. Okay, so while it is deleting, let me check with the code and all. Now it's okay. Now terminal, Terraform init. Terraform validate. Line number 37. So we need to take that random one. Might you have remember? So we need to create one resource block for that main.tf. Number is deprecated region. Okay, if we are not giving number, it will take directly as true. Now it will take. We need to debug like this only. Terraform validate. Yeah, now that error has gone. Now we came to the another error, and that is in output block, output.tf, line number 19. So for writing output block for each, it is different. So now right now I am doing comment on this. Okay. Now 14. Let me comment this. For each we need to change the output block. Okay, we have some different thing here. Yeah, now we have different error on line number 98 of main.tf. You can check here. Okay, missing resource instance key on main.tf line number 98. Okay, main.tf line number 98. Network interface ID. Here we need to write each dot key. Okay, now again we need to validate it. Yeah, now let me ask this ChatGPT what is the error. Okay, means we have to add this. Okay, for each to set. Mm, now the confusion is valid. Now Terraform plan. Uh, Let me ask ChatGPT to write the output. Okay, or we'll see later. Okay. Yeah, now you can see two virtual machine is going to create. Terraform apply auto dash proof. Two VM will create and Nginx will loaded automatically. Okay. Slowly I am going into deep diving. So if you are not seeing my previous video, you are not able to get this. Okay. So be careful while you are watching this video before you have gone through the earlier one. Okay. Oh, the subnet depends on, yeah, we will get some error here because I need to put some dependencies on NIC. So let's see what happened. So while creating, I already explained you too many times. Let me explain this again. Okay. So if you can see the Terraform block, okay, ensure required version, we have Terraform 1.0.0 greater equal to, means ensure that the Terraform CLI version is at least 1.0.0. So if an incompatible version is used, Terraform will throw an error. Okay. So and required provider. So it specifies the provider required for these configurations as Azure RM. You can see here written as Azure RM, means Azure Resource Manager provider for managing Azure resource. Okay. Source, it is written here source. It means that it specifies the provider's namespace, that is Hasikob, and name Azure RM. Okay. And version, if I talk about the version here, ensures the provider version is greater equal to 2.0. It is going to download here. Okay. And random, this another provider we have, required provider we have as a random. Okay. So it's random means generate random values. Okay. For here we use here for creating random strings. Okay. So source, the random provider from Hasikob. Okay. And random, name is random. So version, it ensures the provided version is greater equal to 3.0. Yeah. Uh, apply complete resource 14 added, 0 change. Let me come to the Azure portal. Let me refresh this. Yeah, my RG2, it came. Now we can see 2 VM is created. Okay, 2 VM, 2 public IP, 2 NIC, 2 disk. Okay, yeah, like this we have. So we have done the verification in Azure portal, Azure resource group, virtual network, subnet, 2 public IP, 2 NIC, 2 VM. Okay, and we can access that through public IP, and we can see the Nginx is running. Okay, so let me show you that Nginx is running on that particular VM. Yeah, you can see Nginx is running. If you want to see the another one, VM2, if you'll copy this, paste this, and in this also you can see that Nginx is running. Okay, so now I am doing the cleanup work. So I'll run the command terraform destroy. Terraform destroy. Terraform destroy dash auto dash approve. So it will destroy all the resources what I have created right now, and after that I'll remove my dot terraform as well as tf state. Okay, so we have a simple command for that, rm. Oh, it will take some time to delete it. Okay, so I'll show you at the end. Okay, how to delete that dot terraform as well as terraform dot tf state. Okay, so we can say that for each is preferred over count, and avoid index dash based logic. So for each creates maps. Okay, so resource can be depend on each other naturally. So for each chaining is production ready, I can say. And we have seen the clean scalable readable terraform code. Okay, for 2 VM. Yeah, let me go to Azure portal and do the refresh work here. Yeah, only my VNet is pending. It gone. Now it's time to delete the resource group. Not by manually, it will do automatically. That destroy command I ran from there, it will do. Yeah. So let me see. Successful command is there. Yeah, 14 destroyed. Okay, now I'll show you how to delete the dot terraform. So I'll write rm minus rf dot terraform. Mhm. Let me write. If I'll do star, means it will delete all the dot terraform files. Now terraform dot tf state, rm terraform dot tf state, and I will put star, means it will delete this file as well as this file. Okay, star means all, which having the name terraform.tf state. Yeah, now it is deleted. Okay. So if you found this session helpful, like the video, subscribe to the channel and share with your Terraform friends. Okay. So in the next session, we will go deeper. Okay. So thank you for joining. See you in the next live session. Thank you guys.